Hello, welcome to this overview on the basics of trigonometry. Trigonometry can be confusing to those who are starting to learn it because they feel that they need to memorize how to calculate the sine, cos and tan. However, in this tutorial, I'm going to take you through how you can do this in a more rational manner. The term sine originates from Sanskrit, and then it came through Arabic, then to Latin. In Sanskrit, the word that was used for bowstring is jaya. And when the Arabic scholars wanted to use a term for the chord, which is chord is, if this is an arc, the red is the arc of a circle, and the straight line that goes from one end of the arc to the other is called the chord. This is very similar to a bowstring. And so the bowstring is jaya, and the Arabic scholars translated jaya into jiba. However, in the 12th century, Gerald of Cremona, who translated the Arabic mathematical books into Latin, somehow managed to confuse jiba with another Arabic name jaib, which means bundle, bosom, or fold in a garment, and mistranslated jiba into sine, which also means in Latin bundle, bosom, or fold in a garment, from the word sinus. And the abbreviation of sine is sin. So that's how the etymology of sine comes to us. So if we now look at a circle and look at a diameter, you know from your early maths that if you divide the circumference by the diameter, you always get this ratio 3.14159 and so on. And this holds true for circle of any size. And why that happens, so why it's always this ratio, is for philosophers and theologians. However, we call this number 3.14159 as pi. And so circumference divided by diameter is pi. So circumference is pi multiplied by the diameter, or 2 pi r, where r is the radius of the circle. So what I'm trying to say is that circle has a mathematical property. And now if you look at a circle with a radius of 1, and which makes a angle theta, okay, then what happens is that that's the foundation of your trigonometry. So this is a right angle triangle with a angle of theta here, and we call this hypotenuse, opposite and adjacent. Opposite and adjacent are very obviously understandable, but hypotenuse is always a bit strange word. Hypotenuse comes from through Latin and originally from Greek, and what it essentially means is the line that hangs under the right angle. So this is the right angle, this is the line that hangs under it. Hypo is under, and tenuse is equivalent to a line. So basically hypotenuse, you can say, is the line that hangs under the right angle. So I hope that somehow clarifies that confusion that comes with why it's called hypotenuse. Now if we look at the same circle with the right angled triangle with the angle theta, we know that sine of theta is opposite divided by hypotenuse. But because the hypotenuse in this circle is 1, unit of 1, so the sine theta is O divided by 1, which is same as the sine of theta is the length of O. Or other words, the length of O is the sine of sine theta. And you might ask, so how can I memorize that? But if you go back to that original slide where I mentioned that the word sine comes from the concept of chord, and sine is basically a half a chord, which we will see hopefully in the next slide. So you remember, so this is the arc, okay, and y to n is the chord, and the half of the chord is the sine of theta. So if you remember that how to figure out sine, it's basically half a chord, okay, and the word originally chord comes from, in Sanskrit, the bowstring, and this is the bowstring, half of the bowstring, that's sine, okay. And so once you know the sine of theta, I'll just take you through. So the arc is m, and the y to n is the chord of the arc m, and y to z is half of y to n divided by 2. That is, the y to z is half the chord of yn. So sine of theta is yz, which is half the chord of half the chord. So that's an easier way to remember. So then if you know the sine, which now you know is basically in a unit, in a circle with a radius of 1, the sine of theta is the length of the opposite side. So the next question is, what's cosine? Cosine of theta is basically the sine of the complementary angle. So theta, the complementary angle of theta is lambda, and if you look at the sine of lambda is basically opposite, that's a divided by the hypotenuse, that's h. So a divided by h is your sine of your complementary angle, but that's why the cosine of theta is same as the sine of the complementary angle. The reason it's called cosine is basically because it's the sine of the complementary angle. Okay, so cosine of theta is sine of the complementary angle, that's why it's called cosine. So you now know from sine is basically half a chord, and now you know that, and now so the cosine is basically the sine of the complementary angle, which is basically a, and that's what is the cosine of theta. Okay, so now you know sine and cosine from the first principles. Now the question is regarding tan of theta. So what's the tan of theta? What I will show you is the tan of theta in a unit circle with a radius of 1. The tan of theta is the length from y to e. Okay, so, and I will show you why this is so. Okay, so basically, since the triangle XYZ and the triangle XYE are right angle triangle, because you remember that we drew the tangent to this to XY, and if it is tangent it has to be right angle. Since they are both right angle triangle, YE divided by XY, that is YE, the opposite, divided by XY is equal to YZ divided by XZ. So that means that YE would be basically equal to YZ divided by XZ multiplied by xy. So xy is this one. But since xy is equal to 1, and since in a circle of 1 unit yz, that is yz is sine and xz is cos, so ye is equal to sine of theta divided by cos of theta multiplied by 1, because xy is 1. So that's basically equal to sine of theta divided by cos of theta, and that's tan of theta. So by this, that you see that the ye is equal, the length of the segment ye is equal to the tan of theta. So I hope this tutorial has explained to you from some basic principles how to derive sine, cos and tan. Thank you for your kind attention, and should you have any questions, please don't hesitate to contact me. Bye for now.